Okay, the last section of chapter 12, applications of vectors to mechanics. So very often you will have a question that relates to vectors in mechanics as force, velocity and acceleration are all vectors. So they have not only just magnitude but direction associated with them. So we'll go through one example where you could have a question relating to 3D vectors. So we've got a particle of mass 0.5 kilograms, and there are three forces acting on this particle. You've got the forces given in vector form I, J, K. The first part asks you to find the resultant force. The resultant force is overall force that acts on that particle. So it's simply the sum of all forces. So we need to add all these forces together. I like to write them in a vertical form, easier to do that for adding. So let's do that. And then last one is 4 minus 3 and minus 2, and then you can just add the top components, 2, minus 1 and 4 to give you 5, minus 1, 3 and minus 3 to give us minus 1, and 2 minus 3 and minus 2 to give us minus 3. So overall force is 5I minus 1J minus 3K newtons. Okay, to find the acceleration, we are going to use force is equal to mass times acceleration. The overall force acting on the particle is 5 minus 1 minus 3. So F equals ma. So 5 minus 1 minus 3 is equal to 0.5 times the acceleration, because mass is 0.5 kilograms. So all I need to do now is undo multiplying by 0.5. So if you multiply everything by 2, you get 2 lots of this force. There you go. So acceleration is equal to 10 minus 2 minus 6, or in IJK notation, 10I minus 2J minus 6K meters per second squared. The overall magnitude of this acceleration is obtained by finding the magnitude of this vector. So it's 10 squared plus 2 squared plus 6 squared, all square rooted. Let's just find out what it is. So it's 100 plus 4 plus 36. Square root of this is 11.8 to 3 significant figures. Okay, in the last part we've been asked to find the distance covered in the 6 seconds as the particle moves with the acceleration 11.8 meters per second. So we're looking for the acceleration. So over here we've got, if the particle, actually we're told the particle starts from rest, so we're going to do is S is equal to ut plus a half at squared, where u is equal to 0. There you go. So let's substitute these values into the equation. That's going to be 0 plus a half times 11.8 times 6 squared. So I still got 11.8, so 0.5 times ans times 36. So that will give us 213 meters. There you go. So that's the last example of chapter 12. Now you can go ahead and have a go at exercise 12D and also the mixed exercise. Make sure you do all the questions carefully.